Hello friends, very good morning to all of you. So in our last lecture, we completed all the theoretical part from chapter number 3, Ionic Equilibria, and today let us start the numerical problems based on the topic, different topics included in this chapter. Let us start the first numerical 3.1, problem number 3.1. A weak monobasic acid is 0.05% dissociated in 0.02 molar solution. Calculate dissociation constant of the acid. At the time of solving numericals, first you have to read the numerical carefully. Then you have to write down what is given in the numerical, and after that just write down formula to calculate the required thing and solve the numerical. These are the 4 steps. So a weak monobasic acid is 0.05% dissociated. That means percentage dissociation is given. It is equal to 0.05%. 0.05% means 0.05 divided by 100, and percentage dissociation means it is degree of dissociation alpha. 0.05 we can write 5 into 10 raised to minus 2 divided by 100. 100 means 10 raised to 2. When it comes to numerator becomes 10 raised to minus 2, and hence the total answer is 5 into 10 raised to minus 4 for alpha. Now concentration is given 0.02 molar. Capital M means molar concentration, that is concentration in mole per dm cube. So C is equal to 0.02 molar, which is equal to 2 into 10 raised to minus 2 molar. Now remember this formula, Ka is equal to alpha square C. At the time of studying Ostwald's dilution law, we studied this step, this formula as one of the step of the derivation. Ka is equal to alpha square C for weak acid, and if it is weak base, formula changes to Kb is equal to alpha square C. Put up values. Alpha, it is 5 into 10 raised to minus 4, the whole bracket square, into concentration 2 into 10 raised to minus 2. 5 square 25 into 10 raised to minus 4 in square 10 raised to minus 8 into 2 into 10 raised to minus 2. 25 into 2 50. 10 raised to minus 8 into 10 raised to minus 2 becomes 10 raised to minus 10. So answer is 50 into 10 raised to minus 10, or you may write it as 5 into 10 raised to minus 9. As this one is dissociation constant of weak acid, therefore it don't have any unit. So your final answer, dissociation constant of the given acid, is 5 into 10 raised to minus 9. Let us start the second numerical. Read it carefully. The dissociation constant of NH4OH, ammonium hydroxide, is 1.8 into 10 raised to minus 5. Calculate its degree of dissociation in 0.01 molar solution. Now what is given? NH4OH, that is weak base, is given. Hence its dissociation constant can be given by Kb is equal to 1.8 into 10 raised to minus 5. What is asked to calculate? Degree of dissociation. So alpha is equal to question mark. In its 0.01 molar solution means concentration is equal to 0.01 molar, which is equal to 1 into 10 raised to minus 2 molar. Write the same formula as it is a base, therefore Kb is equal to alpha square into C from Ostwald's dilution law, and hence modify the formula to calculate alpha square first. So alpha square is equal to Kb upon C. Taking square root of both sides, therefore alpha is equal to under root Kb upon C. Put up values. Kb is 1.8 into 10 raised to minus 5, and C is 1 into 10 raised to minus 2. 10 raised to minus 2 to the denominator, when goes to numerator, becomes 10 raised to 2, and convert 1.8 into 18, therefore alpha is equal to under root 18 into 10 raised to minus 6 into 10 raised to 2. Why this conversion is done here? Because we are unable to find out square root of 10 raised to odd number, and therefore we have to write, or we want always 10 raised to an even number, then only we can calculate square root of that number. So I converted here 1.8 into 10 raised to minus 5, 18 into 10 raised to minus 6. 10 raised to minus 6 into 10 raised to 2, 10 raised to minus 4. Square root of 10 raised to minus 4 is 10 raised to minus 2. And square root of 18 you can directly observe in your logarithmic table, logbook or log table. लॉग टेबल मध्ये डायरेक्ट 18चं स्क्वेअर रूट बघू शकता. ते उत्तर आहे 4.242 into 10 raised to minus 2. So the final answer is 0.04242 alpha, that is degree of dissociation. Again, according to the formula of degree of dissociation, it is the ratio of two equal terms and therefore it also don't have any kind of unit. Here is the answer of the numerical. Alpha is equal to 0.04242. Now let us start the third numerical. Next numerical, a weak monobasic acid is 12% dissociated in 0.05 molar solution. What is percentage dissociation in 0.15 molar solution? So first of all, as usual, write down the given thing. Given a weak monobasic acid is given, whose percentage dissociation is equal to 12%. That means dissociation, degree of dissociation is equal to 12 by 100 is equal to 0.12. In 0.05 molar, so concentration is equal to 0.05 molar. What is percentage dissociation? अशा प्रकारचे न्यूमरिकल जेव्हा असतात ज्यामध्ये पहिली कंडिशन दिलेली आहे आणि त्यांच्याच परत सेकंड व्हॅल्यूज दिलेल्या आहेत, त्यावेळेस पहिली जी कंडिशन आहे त्याला नेहमी 1 म्हणायचं. म्हणून पहिला डिग्री ऑफ डिसोसिएशन अल्फा 1, त्याचं कॉन्सन्ट्रेशन C1, जो विचारलाय डिग्री ऑफ डिसोसिएशन तो अल्फा 2 आणि त्याच्या वेळेसचं कॉन्सन्ट्रेशन म्हणजे C2. We have to find out alpha 2 and C2 is given 0.15 molar. Now as acid remains same, acid नाही बदललेलं, जर acid तेच असेल तर त्याचा डिसोसिएशन कॉन्स्टंट पण तोच असतो. म्हणजेच an acid is same, therefore Ka remains same. So first formula, Ka is equal to alpha 1 square C1 and Ka is equal to alpha 2 square C2. Ka constant, so we can equate right sides of both the equations. Hence alpha 1 square C1 is equal to alpha 2 square C2. Modify the formula for alpha 2 square, therefore alpha 2 square is equal to alpha 1 square into C1 divided by C2. Put up values, 0.12 bracket square into 0.05 upon 0.15. 0.12 we can write as 12 into 10 raised to minus 2 bracket square into 0.05 means 5 into 10 raised to minus 2 divided by 15 into 10 raised to minus 2. 10 raised to minus 2, 10 raised to minus 2 get cancelled with each other. 5 ones are 5, 5 threes are 15. So here denominator remains only 3. 12 square is 144 divided by 3 into 10 raised to minus 4. Make this dividation, 3 4s are 12 and again 3 8s are 24. So 48 into 10 raised to minus 4 you may write as 0.0048. This is the value of alpha 2 square. But they are asked to calculate alpha 2 and percentage dissociation. So from this alpha 2 is equal to square root of 0.0048 or square root of 48 into 10 raised to minus 4. Square root of 48 you can directly observe in log table book. 48 square root is 6.93 into square root of 10 raised to minus 4 is 10 raised to minus 2. So final answer is 0.0693 for alpha 2. Therefore percentage dissociation is equal to alpha 2 into 100. So by multiplying 100 with this figure we'll get percentage dissociation is equal to 6.93%. Very simple numerical. Now the fourth numerical you solve yourself. All some examples are of similar type. We are not going to repeat them. Just figures are changed. Remaining pattern is same. Let us start the next type of the numerical. So numerical number 3.5. Calculate pH and pOH of 0.01 molar HCl solution. आता नेहमी लक्षात ठेवा की ज्या वेळेस तुम्हाला कॉन्सन्ट्रेशन दिलेलं असतं पीएच आणि पीओएच काढताना ते कॉन्सन्ट्रेशन नक्की H3O+ आयनचं आहे की OH- आयनचं आहे हे कशावरून ठरवायचं? जर तो ऍसिड असेल तर ते नेहमी हायड्रोनियम आयन कॉन्सन्ट्रेशन असतं आणि जर बेस दिलेला असेल तर ते नेहमी हायड्रॉक्झिल आयन कॉन्सन्ट्रेशन असतं. For example, in this particular example, HCl is given. We know HCl is a strong acid in aqueous medium. It dissociates completely as in the form of H3O plus aqueous plus Cl minus aqueous. H3O plus aqueous plus Cl minus aqueous means whatever concentration given, the acidity is because of presence of hydronium ion and hence the equilibrium concentration of H3O plus is equal to the molar concentration of H3O plus is equal to C is equal to 0.01 molar, that is 1 into 10 raised to minus 2 molar. Now what is formula to calculate pH? pH is equal to negative logarithm to the base 10 of hydronium ion concentration or hydrogen ion concentration H3O plus ion. Put up value 1 into 10 raised to minus 2, remaining all is same. So pH is equal to negative logarithm to the base 10 of 1 into 10 raised to minus 2. Now how to solve this? इथे डायरेक्ट आन्सर लिहिलंय. तुम्हाला वाटत असेल डायरेक्ट आन्सर कसं काय आलं? याचं सिम्प्लिफिकेशन मी तुम्हाला या साइडला दाखवते बघा. Our step is this. pH is equal to negative logarithm to the base 10 of 1 into 10 raised to minus 2. Simplify this. Minus sign carry as it is. Logarithm to the base 10 of 1 plus multiplication मध्ये log plus मध्ये जातो plus logarithm to the base 10 of 10 raised to minus 2 is equal to minus sign ने multiply करून घ्या प्रत्येकाला. Minus logarithm to the base 10 of 1 minus plus minus logarithm to the base 10 of 10 raised to minus 2. Answer for log 1 is 0 म्हणजे minus 0 म्हणजे झालं डायरेक्ट 0 minus log of x raised to n is n into log x म्हणजे ते येईल minus 2 into logarithm of 10 to the base 10 is equal to minus minus become plus 2 into logarithm of a to the base a is always equal to 1, so 2 into 1 and the final answer is 2. एवढ्या सगळ्या स्टेप्स परफॉर्म करण्याऐवजी तुम्ही डायरेक्ट उत्तर लिहू शकता आणि डायरेक्ट उत्तर लिहिण्याची मेथड काय आहे ते सांगते. जेव्हा हा फॉर्म्युला आहे pH is equal to negative logarithm to the base 10 of anything into 10 raised to negative factor, then directly write down 10 raised to that negative factor instead of negative positive. डायरेक्ट ते लिहा. त्याच्यानंतर मायनस log of this first number. इथे log 1 ची किंमत 0 आहे म्हणून पुढे काहीच नाही आलं आणि डायरेक्ट आपलं उत्तर आलं 2. अजून पुढच्या काही न्यूमेरिकल्स मध्ये तुम्हाला परत समजेल की हे कॅल्क्युलेशन डायरेक्टली कसं येतं. ओके, हियर इज द न्यूमेरिकल नंबर 3.5. नाउ लेट अस स्टार्ट न्यूमेरिकल नंबर 3.6. Next numerical is pH of a solution is 3.12. Calculate the concentration of H3O plus ion. Direct question is asked in this numerical. Concentration of H3O plus ion is asked to calculate and pH is given 3.12. So these are the given things. Again the same formula. Don't forget this formula, very important formula. pH is equal to negative logarithm to the base 10 of H3O plus ion concentration. Put up values. 3.12 is equal to negative logarithm to the base 10 of H3O plus ion concentration. Minus sign comes here, so minus 3.12 is equal to log to the base 10 of positive log to the base 10 of H3O plus ion concentration. That means logarithm to the base 10 of H3O plus ion concentration is equal to, we can write minus 3.12 as minus 3 minus 0.12. Now please look here and try to understand what is happening here. Why we are writing that number minus 3.12 as in the splitted form. Minus 3.12 indicate that both characteristic and mantissa are negative. Both characteristic and mantissa are negative. But when we are taking log or antilog of any term, at that time characteristic may be positive, negative or 0, but mantissa should always be positive. डेसिमल पॉइंट नंबरचे जे आकडे असतात ते कंपल्सरी पॉझिटिव्ह असले पाहिजेत. -3.12 चा अर्थ होतो -3 -0.12 डेसिमल पॉइंट नंतरचे आकडे निगेटिव्ह आहेत असं असेल तर गणित पुढे सोडवता येत नाही. अशा केस मध्ये कंपल्सरी +1 -1 ऍड करायचे. ऍड +1 -1. निगेटिव्ह टर्म जी आहे -1 ती तुमच्या निगेटिव्ह सोबत घ्यायची म्हणजे -3 -1 नंतर +1 लिहायचा आणि नंतर उरलेली टर्म लिहायची. म्हणून इक्वेशन झालं -3 -1 +1 -0.12. नाउ -3 -1 मीन्स -3 -1 मिळून झालं -4 प्लस 1 -0.12 आन्सर इज 0.88. इन्स्टेड ऑफ रायटिंग आता बघा कॅरेक्टरिस्टिक झाला निगेटिव्ह आणि मॅन्टिसा झाला पॉझिटिव्ह. कॅरेक्टरिस्टिक निगेटिव्ह कॅन बी रिटन डायरेक्टली ॲज bar4 and 0.88. Therefore, logarithm to the base 10 of H3O plus ion is equal to actually bar4 0.88. फक्त तुमच्या -3.12 ला आपण कशामध्ये कन्वर्ट केलं bar4 0.88 मध्ये कन्वर्ट केलं. Now simple step taking antilog of both the sides म्हणजे हा log निघून जाईल. H3O plus ion concentration is equal to antilog of bar4 0.88. 0.88 चा शून्य मध्ये जर antilog बघितला तर तो येईल 7.586 into 10 to the power -4 is the final answer for H3O plus ion concentration. Next, let us start the next type of the numerical. Numerical number 3.7. A weak monobasic acid is 0.04% dissociated in 0.025 molar solution. What is pH of the solution? What is asked to calculate? pH is equal to question mark. What is given? Concentration is given 0.025. HA is a weak monobasic acid. As it is weak acid, it dissociates in aqueous medium at equilibrium to give H3O plus aqueous plus A minus aqueous. Percentage dissociation is equal to 0.04%. Therefore, alpha is equal to 0.04 upon 100. 0.04 means 4 into 10 raised to -2 upon 100 means 4 into 10 raised to -4. Now remember, for any weak acid or weak base, its molar concentration can be calculated with the help of this formula. Remember, for any weak acid or weak base, मगाशी गणित जे आपण बघितलं होतं त्यामध्ये HCl हे स्ट्रॉंग ऍसिड होतं, त्यावेळेस आपण डायरेक्ट फॉर्म्युला वापरला होता. हे वीक ऍसिड आहे, याचा फॉर्म्युला आहे अल्फा इंटू सी. डिसोसिएशन कॉन्स्टंट जर दिलेला असेल तर फॉर्म्युला असतो अल्फा स्क्वेअर इंटू सी. पण डिसोसिएशन कॉन्स्टंट जर दिलेला नसेल तर फॉर्म्युला असतो H3O plus ion concentration is equal to alpha into C. Put up value. Alpha is equal to 4 into 10 raised to -4 and concentration 0.025. 0.025 means 25 into 10 raised to -3. 25 into 4 100. 10 raised to -4 into 10 raised to -3. 10 raised to -7. 100 means 10 raised to +2. So final answer is 10 raised to -5 molar is the H3O plus ion concentration. But they are asked to calculate pH. pH जर काढायचं असेल तर आधी H3O plus ion concentration लागतं आणि ते आपण मिळवले. आता pH चा फॉर्म्युला लिहा. pH is equal to negative logarithm to the base 10 of H3O plus ion concentration is equal to, put up value, negative logarithm to the base 10 of 10 raised to -5. 10 raised to -5 म्हणजेच 1 into 10 raised to -5. आत्ताच थोड्या वेळापूर्वी मी सांगितल्याप्रमाणे जेव्हा निगेटिव्ह लॉगॅरिथम टू द बेस 10 1 into anything into 10 रेस टू निगेटिव्ह फॅक्टर असतो त्यावेळेला 10 रेस टू चा जो पॉवर आहे तो डायरेक्ट पॉझिटिव्ह करून लिहा. दॅट इज युअर फायनल आन्सर. pH इज इक्वल टू 5. कसं आलं हे उत्तर? परत एकदा त्या स्टेप्स जर एक्सप्लेन करायच्या असतील तर आपलं कॅल्क्युलेशन आहे निगेटिव्ह लॉगॅरिथम टू द बेस 10 ऑफ 1 into 10 raised to minus 5 इज इक्वल टू काय करणार आपण? लॉगला सेपरेट करणार. निगेटिव्ह लॉगॅरिथम टू द बेस 10 ऑफ 1 प्लस ब्रॅकेट टाकूयात आपण. निगेटिव्ह साइन बाहेर ठेवला आपण आधी ब्रॅकेटच्या. 1 प्लस लॉगॅरिथम टू द बेस 10 ऑफ 10 रेस टू मायनस 5. निगेटिव्ह साइन ने मल्टिप्लाय केलं. मायनस लॉगॅरिथम टू द बेस 10 1 मायनस प्लस मायनस लॉगॅरिथम टू द बेस 10 ऑफ 10 रेस टू मायनस 5. पुढे काय केलं आपण? log 1 इज 0 म्हणजे हे आन्सर आलं 0 मायनस log ऑफ x रेस टू n इज n into log x. log of 10 to the base 10. log of 10 to the base 10 is 1 minus minus plus and the final answer is 5. एवढ्या स्टेप्स करण्याऐवजी ते डायरेक्ट उत्तर लिहिता येतं तसंच चालतं अलाउड असतं त्यामुळे आन्सर फॉर pH is equal to 5. Now let us start the next numerical of the chapter. Let us start the next type of the numerical. Calculate the pH of buffer solution composed of 0.1 molar weak base BOH and 0.2 molar of its salt BA. So concentration for weak base is given, therefore molar concentration of base is 0.1 molar and concentration for salt is given, therefore molar concentration of salt is equal to 0.2 molar. Now whenever buffer solution is there at that time, always remember the formula which is given by Henderson-Hasselbalch equation. Those two formulae for acid and for base. Whenever base is given, formula is like this: POH is equal to pKb plus logarithm to the base 10 of molar concentration of salt upon molar concentration of base. जरी आपल्याला pH विचारलेला असेल पण दिलेलं सोल्युशन हे काय आहे? वीक बेस. वीक बेस मध्ये अगोदर POHच काढावा लागतो आणि POH काढल्यानंतर त्यावरून आपल्याला pH काढता येतो. सो अकॉर्डिंग टू Henderson-Hasselbalch equation, here concentrations we written here given from given thing, and we know the second formula pKb is equal to negative logarithm to the base 10 of Kb. Put up value of Kb here. So negative logarithm to the base 10 of 1.8 into 10 raised to minus 5. आता सांगितल्याप्रमाणे हे कसं सोडवायचं? तर 10 raised to जो निगेटिव्ह फॅक्टर आहे तो डायरेक्ट लिहा मायनस लॉगॅरिथम ऑफ जी टर्म असेल. आतापर्यंत log 1 असायचं म्हणून आपलं डायरेक्ट 0 असायचं हे, पण आता इथे log of 1.8 to the base 10. log of 1.8 is 0.2553. By making this subtraction, we'll get pKb is equal to 4.7447. Put this value of pKb, concentration of salt and concentration of base in the Henderson-Hasselbalch equation. We get POH is equal to 4.7447 plus logarithm to the base 10 of 0.2 upon 0.1 means it is log 2. Log 2 is 0.3010 and this summation comes 5.0457. So POH is equal to 5.0457. But we know the relation pH plus POH is equal to 14. Next formula. pH plus POH is equal to 14. Therefore, pH is equal to 14 minus POH. Hence, pH is equal to 14 minus 5.0457. Answer comes 13.9543 or approximately you may write down as 13.95. Don't round up the answer. Okay? Here is the answer for pH. Now the next numerical is numerical number 3.12 and last numerical of today's session. The solubility product of AgBr silver bromide is 5.2 into 10 raised to minus 13. Calculate its solubility in mole per dm cube and gram per dm cube. Given molar mass of silver bromide is equal to 187.8 gram per mole. Let us solve the numerical. The salt given is silver bromide AgBr, which is a sparingly soluble salt. A sparingly soluble salt means dissociate at equilibrium in the form of Ag plus aqueous plus Br minus aqueous. Here x is equal to 1 and y is equal to 1, the balancing coefficients in the balanced chemical expression. So KSP, solubility product, is equal to equilibrium concentration of Ag plus into equilibrium concentration of Br minus. According to our formula, KSP is equal to, remember this formula, KSP is equal to x raised to x into y raised to y into s raised to x plus y. Put up values, therefore we'll get relation between KSP and S for this particular salt as KSP is equal to S square. Hence solubility is equal to square root of KSP. Put up the value of KSP given, it is 5.2 into 10 raised to minus 13. That is 52 into 10 raised to minus 14. Square root of 52 is 7.2 and square root of 10 raised to minus 14 is 10 raised to minus 7. But this answer of solubility is in mole per dm cube. This one is a molar solubility. Whatever we are finding from this formula, it is nothing but a molar solubility. Molar solubility means solubility in mole per dm cube. But they are asked to calculate solubility in gram per dm cube also. So, how to calculate solubility in gram per dm cube? It is equal to molar solubility in mole per dm cube into molecular mass in gram per mole. It is given in the numerical. So, 7.2 into 10 raised to minus 7 into 187.8. How to solve this? 10 raised to minus